Okay, let's start today's lesson by solving this system of equations, linear equations, and we are going to use what we have been learning on finding inverses of matrices to proceed with this problem. So first, let's go ahead and set this set of equations in matrix form. But first you will notice that these equations are not set up in standard form. So let's first do that. So we have 4x, the 5y will come over as plus 5y equals a 5. And then we have 5x plus 3y, and the 16 will go over and become positive 16. So if we write this in matrix form, we'll write only the coefficients of x and y in one matrix, and then we will multiply by x and y, which are our variables, and set it equal to our constants 5 and 16. So if we were to expand, multiplying row by column equals this constant and row by column equals this constant, we would have the given equations in our problem. Okay, so since we are looking to solve for x and y, our goal is to isolate x and y. So what we're going to do is multiply the inverse matrix of 4, 5, and 5, 3 on both sides in order to get our identity matrix here on this side. Okay, so in essence, I am doing this. I'm taking 4, 5, 5, 3, and I am going to multiply it by this. So that we get the identity matrix. And in so doing, we have isolated the x and y. Okay, so we need to go find this matrix, okay? Let's call this matrix A. So let's find A inverse, which in order to do that, we are going to proceed by finding the determinant. Okay, let's find, gosh, I can't write and talk. Let's find the determinant of A, which will be done by so 4 times 3 is 12, times 5 is 25. When we subtract it, we get a negative 13. So we do that so that we can find our A inverse. So we take the 1 over the determinant, which is negative 13 in our problem, and we are going to interchange some numbers here. So this diagonal becomes a 3 and a 4. Those numbers switch. And then these numbers right here are going to, whoops, you can't see what I'm writing. These numbers right here are going to switch signs. They don't switch order. They just change signs. So this 5 became a negative, this 5 became a negative, and these, they just interchange, okay? We are going to distribute this value to all 4 numbers. And I have to make this a little taller since we have some fractions here. So we're going to end up with a negative 3/13, a 5/13, another 5/13, and a negative 4/13. So we have found this entire value here, this A inverse right here. So we're going to substitute what we found into this spot right here so that we can find our xy. So I'm going to rewrite. Okay, so let me do that. So let's see if you can see everything. Okay, so let's substitute this A inverse with what I just found. So xy, our xy is going to be the inverse we found times the 5/16, not the 5/16, the 5 and 16. And now we're going to multiply row by column, row by column, row by column to find our final answer. So these pair numbers are going to multiply with this pair. So negative 313 times 5 is going to be negative 15 over 13 plus the 5/13 times 6 is going to be 80/13. And then we're going to do the same thing. 5/13 times 5 is 25/13 plus negative 4 times 16, or negative 4/13 times 16 will be negative 64/13. Let's simplify. So negative 15 plus 80, we get 65/13. 25 plus negative 64 is negative 39 over 13, which again, we reduce these fractions, and we get a 5, and we get a negative 3. So all of that to say that x is 5, x is 5, and our y is negative 3. Okay? So here's what we learned the last time, okay? This is how we solved our x and our y in our last lesson. So I want to show you, introduce to you another method of solving systems. But this time we are going to use Gaussian elimination and row echelon form. So we're going to do this same problem using another method. Okay, all right, so here we go. We're going to set up this problem. Okay, so this is page 71 in your text. And I'm going to rewrite the problem. But this time, we are going to write it where, well, let me write it first, and then you can see the setup. So 4x plus 5y equals 5, and we had 5x plus 3y equals 16. So we're going to create an augmented matrix, and the constants are going to be on the right side of a vertical line within the matrix, similar to what we had done before. So here we go. I'm writing the x column, I'm writing the y column, and then I'm going to put a vertical line, and then I'm going to write on this side of the vertical line the constants. Okay, and my goal is to get ones here and zeros here, and in so doing I'll end up solving for x and y. So here's how you're going to do this, just like we've done in the past. Now, there are many ways of approaching this particular problem. Okay, so I am going to try and get this to be a 0. Okay, and in order for me to do that, I am going to look at the lowest common multiple between 4 and 5, and it is a 20. So I'm going to force this to become a 0, by multiplying this row by 5 and this row by 4, and then subtracting them, okay? So visually, just to help you see it, some of you can do it totally in your head. I'm going to just show all the work steps just to make it easier for some of you. Okay, so I'm going to multiply the top row by 5 and the bottom row by -4. Again, there are many different ways that you can do this. So I did 5 times row 1 and -4 times row 2, just in case you're wondering what I did, okay? And the reason I did that is because now I want to add row 2 to row 1 to be able to get a 0, okay? So I'm going to bring this 20, 25, and 25 over, and when I add that, I'm getting -20, oh yeah, 0, -20 plus 20 is 0, -12 plus 25, I'm getting 13, and -64 plus 25, I'm getting a 39. Okay. Now, remember I told you that this diagonal, I want it to be a 1, so I'm going to multiply row 2 by 1/13. This row is not changing. This is going to become a 1, and that's a -3. Okay. Now I am going to work on this side. I'm trying to get this one to become a 0. And what do I need to do? Well, I'm going to multiply row 2 by -25, and then I'm going to add it to row 1. Okay, so I'm going to put here this one right here because I'm not changing anything on this one. So -25 times 0 plus 20 will still remain as 20. -25 times row 2, the 1 is -25. At -25 plus 25 will become a 0. And then -25 times -3 is going to be positive 75. Positive 75 plus 25 is 100. Now, I will want to get this number to become a 1, so I am going to multiply row 1 by 1/20, or divide by 20, and so that will become a 0. If I did divide this by 20, it's still going to be 0, and this number by 20 is going to be a 5. So how do I read this? Well, remember this 1 is in the x column, and this 0 is in the y column, and then we have our constants. If I rewrote this back in linear equation form, I'm in essence writing 1x plus 0y equals 5, and 0x plus 1y equals -3. Well, 1x is usually just written as x, 0 times y is just nothing, and 0 times x, nothing, no need to write that. 1 times y is just a y. Our 1 is understood to be there. So you ended up solving a system in this situation. So notice how this answer is the same as the process that you used over here. The only difference is over here you multiplied the inverse by this matrix, and you had to find the inverse using your determinant knowledge, and then you had to do row by column to simplify. Okay, so just another method for you to practice using. Okay, so now if you would come along with me and turn your text page to problem number 7. Okay, so let's go to problem number 7. Let me shift my paper up here a bit. Okay, in problem number 7, the setup was following: 3x plus plus y minus 2x plus 2y plus z equals 9. And then we had negative x minus y plus 3z equals to 6. So let's go ahead and rewrite these using this method that we just learned. Let us practice. Okay. All right. So remember, we did these type of problems in the past where we were looking for an inverse. So we wrote these down, and like that. And we were finding the inverses. And now we're using matrix, our knowledge of matrix manipulation with augmented matrices in order to solve a system. So here we go. 3, 2, negative 1, 1, 2, negative 1, negative 2, 1, and 3. Bring this down. Negative 7, 9, and 6. Okay. This is our x, our y, and our z. And these are our constants. And make sure I copy these right with all my correct signs, because that would be a mess if I miswrote that. Okay, so here we go. First thing we're going to do is let us convert this into a 0. So I am going to multiply this row by 2, and I'm going to add it to this row right here. Okay? So 3, 1, negative 2, and negative 7 are not changing. This is not changing. This is about to change. So multiplying row 3 by 2, and then I'm going to add row 2 to it. So negative 1 times 2 is negative 2 plus 2 is 0. Negative 1 times 2 is negative 2 plus 2 is 0. 2 times 3 is 6. 6 plus 1 is 7. 6 times 2 is 12. 12 plus 9 is 21. Okay. All right, what's our next step? Well, right here, I can divide this by 7, because I know this diagonal here, I want it to be 1s. So I can divide this by 7, actually, and be done with it. So why not do this? Let's just do 1/7 of row 3. And so I'm going to change this 7 into a 1. And if you want, we can do this. Let's just do this. That becomes a 1, and that becomes a 3. So I don't have to write the whole thing all over again. Okay, let us see. So the next thing we're going to do is I want to, what do I want to do? How about, well, this is a 1. I know I need to make this a 0. So how about do, subtract these rows? Let's do that. So let's do row 2 minus row 3 in order for us to get this position here to become a 0. So let me write down what's not changing. 0, 0, 1, 13. All right, so let's do row 2 minus row 3. So 2 minus 0 is going to be a 2. 2 minus 0 is going to be a 2 again. 1 minus 1 is going to be a 0. And 9 minus 13 is going to be a negative 4. Am I doing that right? Oh, 9 minus 3 is a 6. It's like 13. Okay, here we go. Let me scoot this over a bit. Alright, so this looks like a 13, it threw me off, so let's make that more like a 21. Okay, now what am I doing next? So I got that 1 to become a 0, so I have zeros here. What do I need to do next? Well, let's do this. I can make this row, I'm going to multiply this row, let's see, by half row 2. So I'm going to do this, I'm going to make this a 1, this is going to become a 1, that stays a 0, and that's going to become a 3. So I can do that, and then what I can do is I can make, let's multiply, okay, let's make this a 0. I'm going to choose that because I have a 1 in this column, and so I know if I multiply row 3 by 2, and I add it to row 1, I will be able to change this one. So my goal is to change this one. So these rows are going to be the same. So let's make this, let's write this down. 0, 0, 1, 0, and the 3 are going to stay there. So this is what's changing. Okay, so my rule is 2 times row 3. So 2 times 0 is 0. 0 plus 3 is going to be a 3. 2 times 0 is 0. 0 plus 1 is going to be a 1. And 2 times 1 is going to be a 2. 2 plus negative 2 is going to be a 0. And then this is going to be, did I say 13 again? Oh my goodness, you see what I did here? I made that a 13 again. That's a 3. Anyway, 2 times 3 is 6. 6 plus negative 7 is a negative 1. Okay. There we go. Alrighty. So now we made that into 0. So we're looking pretty good here. Now let us try and get another 0. Let's try and get this to become 0. Okay. And we're going to do that by looking for the other 1 in that column. And let's do row 2 minus row 3. Yes. So row 2 minus row 3, because 1 minus 1 will give me 0. So the 2 rows here are not going to change. 1, 1, 0, 3, 0, 0, 1, 13. Row 2 minus row 3. So 1 minus 3 is negative 2. 1 minus 1 is 0. 0 minus 0 is 0. 3. 3 minus negative 1 is a 4. And then look here, this is awesome because right here I just need a 1. I've got my 2 zeros, so I'm going to go ahead and change that by dividing it by negative 2. So I'm going to multiply row 1 by negative 1/2. So that's going to become a 1, and this is going to become a negative 2. These are just going to stay 0. And now my goal is to get this to be a 0. And so now that I have a 1 right above it, I can subtract them. So I can do row 2 minus row 3. So let's first bring this row over and the third row over. And look at me. I am still writing 13 like crazy. Incredible how I'm just insistent about writing that 13. Oh my gosh, that's so aggravating. Okay. And then what are we doing? Row 2 minus row 3. So 1 minus 1 is a 0. 1 minus 0 is a 1. 0 minus 0 is a 0, and 3 minus negative 2 is a 5. So here you notice we have our x column, in this column we have our y, and in this z column we have our 1. Let me bring this down a little bit more. So we have arrived to our solution where x is a negative 2, the y is a 5, and the z is a 3. So this method helps us a lot in solving 3 by 3 matrices, because imagine having to solve this matrix here with the first method we did. In other words, with this method here, we would have arrived to the setup where we had the inverse of the 3 by 3 matrix here times, our 3 by 1 matrix here, and finding the inverse of this matrix would have required us to do some augmentation as well. So if we're going to do that, why not just go ahead and set it up in this manner and use our knowledge in creating these matrices where the x, the y, and z will be isolated through doing row reduction and arriving to our final answer. So here you are, learning yet another method. So now it's your turn to practice. Thanks for watching.